All right, in the previous part, we looked at how you could take ownership of an attribute by defining a property. Just to refresh your memory on that, what we did is we made a class where we defined price and shares as properties. And by doing that, we were able to capture what happens when people access attributes. Like the attribute behaves normally, but then if somebody puts in a bad value, we were able to catch that and generate an error. Again, very cool thing to know about if you're trying to lock down the environment or lock down what an object does. Now, one downside of the code that we wrote actually just concerns how verbose it is. Up at the top, I've got these properties defined. Think about the problem of doing this on dozens or hundreds of class definitions. Let's say you decided that properties were like a really interesting thing. Maybe type checking was an interesting thing. Let's say you wanted to do that in like hundreds or thousands of places in your code. Do you have to type in this property code every single time you do it? That would be extremely annoying, actually. And so I want to look at a different way of tackling this problem. And in order to do that, we have to tie two different things together. The first thing that we have to revisit is just the representation of an instance itself. Turns out that this H that I've created, underneath the covers, there's a dictionary that is holding the data. When I access an attribute like h.name, what that's doing is it's taking that out of the dictionary. Same thing, like if I were to set name, that's the same as going into the dictionary and changing the value. First thing, objects are doing dictionary manipulation. The second thing that I have to talk about is just how in the world does this property thing intercept the dot? Like, what is the magic that drives that? If I say h.shares equals 100, how is it intercepting that? So here's how that is working. On every instance, keep in mind there's a record of what class it belongs to. For this H, it says that it's part of the holding class. Turns out that how properties work and how attribute access work is that when you look up an attribute, like you say h.shares, for instance, Python will actually consult the class for that first. And it will say, hey, class, do you know anything about that? Technically, it actually pulls it out of a dictionary for the class. What happens is this property object comes back. Let me save that. So P, okay, here's a property object. Having seen that in the class, the next thing that Python will do is it will look at it and it will ask it, do you happen to have a get method? There's a special method _get. And if that comes back as true, what Python will do is it will fire the get method to get an attribute. Like if you want to get an attribute, it would say, hey, okay, I'm going to do a get. Here's the H or the instance that I'm working with. Go ahead and return it back. It's like, all right, 100. The same thing actually happens when you set an attribute. Like if you want to know, like, how does that work? Or like, how does shares equal 100 work? Or how does it catch a bad value? What happens is Python will look at this property attribute. Again, it will say, okay, let's go to the class, look in the dictionary. Do we know anything about shares? Okay, there's a property object. It will ask it, hey, do you know how to do a set? And if it comes back as true, Python will fire that, sort of saying, okay, you know how to do a set. I'm going to hand you the H along with the value. You do the set. So it turns out that the dot is mapped to this get and this set machinery underneath the covers. Officially, what this is known as, this property, is an example of something known as a descriptor. Essentially, a descriptor is an object that implements the dot. It implements the get, set, and delete operators. And so knowing that that is how it works, here's the thing that you can do. I have this code that implements properties. What I'm going to do is I'm going to drop down to a lower level, and I'm going to kind of take the idea there and use it. What I'm going to do, I'm going to make a new file over here called validate.py. The purpose of this is to do type validation. I'll start with a class called maybe integer, like this. What I'm going to do is I'm going to put on this class a get method, and I'm going to put a set method. I'm going to fill out the details in a second, but the idea is that I'm going to implement this thing that we just saw with properties. Basically, the dot uses get and set. I'm going to plug into that. So I'm going to make a class that has a get and a set. And then what I'm going to do is do this like type checking thing. So in the get or in the set, I'm going to do the type check. If not is instance value int, raise a type error. Keep in mind that this is the code that I'm getting over here. I'm basically taking that, putting it into the set, saying if the value is not an int, we're going to raise an error. And then I have to carry out the set. Now, this is where this business of manipulating the dictionaries comes into play. If you go back to the earlier example, how did you get something to save an attribute? Well, the way that you do it is you manipulate the instance dictionary. So I'm going to come in here and I'm going to take that instance, I'm going to go into the dictionary, and I'm going to set a value. Now, I have a problem here, which is what do I use there? I have to know where I'm saving this thing. So on this integer object, I'm going to give it an attribute name that sort of indicates where is this thing being saved exactly. Okay, so I'm going to give it a name, sort of you're saving it there. And it turns out that the get method is going to do kind of the opposite of that. So the way that you get an attribute is you reach down into the dictionary and you pull it out. Okay, so I've got two different things kind of coming together here in this integer class. I'm manipulating the instance dictionary, which is how attribute access works. And then I'm plugging into this get and set machinery that you see properties using. Now, why would I do that? So where is this going exactly? Here's where this is going. If I had a class, I'll make like a point class just to illustrate this. I can come in here and declare attributes using that integer class. I can come in here and I can say x is an integer, y is an integer. And then I can write the rest of my normal Python code in here. I could say, have an init function and so forth. And if you do that, you're going to find that those attributes now have magic attached to them. I can come in here. Let's load that validate class. I can say p is equal to 0.23. You will find that this p object has an x and a y. Everything about it looks completely normal. In fact, if you look at the dictionary, you'll see the data sitting there. However, if you set a bad value, it blows up at you saying, no, you can't do that. You need an int. Again, I've taken ownership of the dot, but I've done it using a much lower level mechanism here. This class that I've made, again, this is something known as a descriptor. I'm plugging kind of directly into that machinery and taking over that. One thing about what I've done here, this class that I've made for integer, it has to be used at the class level. It has to be at the outer level here, not in the init function, at the outer level. Think of this integer class as a kind of like manager or supervisor. I mean, what it's doing is it's supervising this X attribute and kind of overseeing what's happening there. In order to do that supervision, it needs to be at the class level. So it's overseeing that attribute. The other thing is that it only applies to X and Y. I can freely access other attributes, like Z, for instance, and it doesn't care about that. It's only singularly focused on the X and the Y. That's kind of a neat thing that is possible. And then where this is going is I could take this idea and maybe extend it out to have other types, for instance. Like I could have a float type, for instance, that would do a different kind of type checking. I could say, well, we're checking for a float. And then we could start to build out kind of a more featureful class. I could say, well, we have a holding object and the shares is equal to an integer of shares. And price is equal to a float of price. And then what you're going to start doing is building some validation into this class. Maybe we'll just do that to start. One thing to think about is how this compares to the code that's over on the left. One of the things that you'll find is that this code here is way simpler than this code over on the left. I'll put cost on here as a property just to mirror some of the functionality that we had as well. Okay, so we have a much simpler class here. You'll find that it actually behaves in pretty much the same way as the other class, again, but with much less code. Okay, so now we have our holding object, we have shares. You're going to find that this thing is now catching things like type error. It says, oh, you need a float for that. Or if you put shares as a lot, you're catching that. This sort of thing, this becomes far more useful if you start writing libraries and frameworks. The idea that you can take that custom attribute you can package it up into something that's more reusable. And then you don't have to do like tons and tons of this like cut and paste coding that you have over on the left. I thought I would leave you with one way to kind of simplify this code a little bit. You'll notice that these integer and float classes, there's kind of a lot of overlap between those two classes. One of the things that I might want to do is I could use inheritance to kind of simplify this a little bit. Like I could make a typed class where you give me a name. Actually, maybe even the get could go up into there. And then what I could do is make those classes inherit from typed. I'm just thinking about ways to reuse some of the code, not have so much repetition on it. I could also simplify this get method if I were to kind of generalize that as well. One of the things that I could do, I could have like an expected type class variable in here, and then I could take one of these set methods and actually check it against that. We're going to check against an expected type of some sort. And then what I could do in these subclasses is fill in the expected type. This is kind of a neat trick for greatly reducing the amount of code that has to be written. Maybe I could even put a string class in here to kind of flesh it out a little bit. Now what you've got is you've actually maybe even constructed like a little mini type system or something for Python. Actually, I'll leave the date alone. That's a little weird there. But I could do enforcement, name is a string, shares is an int, price is a float. Just writing, one of these little descriptor objects that ends up enforcing types. Let's actually make sure that that works before we finish up here. So there's an object. It should be enforcing a type on the name. Okay, good. It should be enforcing a type on shares. And it should be enforcing a type on the price. Again, taking ownership of the dot, this is a lower level mechanism that drives properties. Very useful if you're writing larger frameworks and libraries.